Good morning student. Today we will learn how to calculate pharmacokinetic parameter using Excel. I am a Dr. Inayat Bashir Pathan, Assistant Professor, Government College of Pharmacy, Aurangabad. So we will see the learning outcomes of this session. After watching this video, the student will be able to calculate pharmacokinetic parameter such as elimination rate constant, volume of distribution, T half by using the Excel. Now we will see how to calculate the pharmacokinetic parameter using the Excel and different parameters such as elimination rate constant, volume of distribution, clearance and T half. Now before going to this calculation of pharmacokinetic parameter, one should know what are the different equations, formulas to calculate these pharmacokinetic parameters. So now first we will see the elimination rate constant, which is calculated by Ke is equal to slope into 2.303. So this is formula to calculate the elimination rate constant. To calculate this elimination rate constant, we have to remove the slope. So now this slope is removed by using the log concentration versus time plot. We will get the straight line, like this straight line will get, and this we have to remove the slope of this straight line, and that slope is equal to minus Ke divided by 2.303. So from this we can calculate the elimination rate constant. Now minus value is due to the decrease in the concentration. Next is the parameter is the half life. Half life is calculated by T half is equal to 0.693 divided by Ke. Now 0.693 divided by Ke, here we can calculate after removing the Ke, we can add this Ke value in this equation and we can remove the T half. Next is the volume of distribution. So formula to calculate the volume of distribution is equal to Vd is equal to X divided by C0. That is X0 is nothing but the initial dose which is given to that patient. Now that is an IV bolus dose divided by the plasma drug concentration. Next is the clearance. So the formula to determine the clearance, that is the Ke into Vd. So we have removed the Ke from this first equation, elimination rate constant, that will put the value of Ke and Vd and will get the clearance. Now we will see what are the different units for this parameter. Elimination rate constant having an unit, that is per hour. Half life which having a unit, that is the hour. Volume of distribution in liter and clearance is liter per hour. So now we will go for the actual removing this parameter. Now this is the problem that we have to remove all this parameter. Now here we will remove the example is a 50 kg woman was given a single IV dose of antibacterial drug at a dose level of 6 milligram per kg. So this is the dose which is given to that woman, and next is the blood samples were taken at various time interval. The concentration of drug was determined in the plasma, fraction of each blood sample, and the following data was obtained. Now after removing the blood sample from that woman, so this data which is given, that is for up to the 6 hour, the concentration is at first hour, that is the plasma concentration in microgram per ml, that is the 30 microgram per ml to 20 microgram per ml. At 3 hours is 10 microgram per ml. Like this the concentration goes on decreasing. Next, now we have to calculate the volume of distribution, Ke, T half and clearance from this data. Now before going to this, what we have seen previously, how to calculate this. Now first we have to plot the graph, that is the log concentration versus time. So from this we can remove the slope and we'll add the value of the slope in this formula and we'll remove the Ke. Now we'll start. So before going to removing, first we have to convert this plasma concentration into the log plasma concentration. So we'll remove that by adding the formula, that is equal to log. So in this we will add this value. So in this you have got this value, that is 1.4 is the log value of this 30. You drag this so that we'll get the whole value. No need to add every time. Now we'll draw the graph. we have to draw like this graph, log concentration versus time. So in this we have to go in the insert, scatter, add the value, select data, add. So at x-axis what we have to add, at x-axis we have to add the time, and at the y-axis it will be the log plasma concentration. Okay, so in this way we have got this graph. So here will so at y-axis at the y-axis is the plasma log of plasma concentration versus time. So this time will be in the hour. Next we have to remove now slope of this straight line, what we have seen previously, like this graph we have got. Now we will remove the slope. So for removing the slope you have to click on this straight line, and I have to go in the add trade line. After going in the add trade line you have to display the equation, you have to click on the display equation. Okay, then close. So like this you will get the equation, that is nothing but the slope of this line. So we have got the slope, that is y is equal to mx plus c equation, that is y is equal to m means slope, that is a minus 0.28 and plus 1.8. 1.8 is nothing but this is the intercept. So now we will write here slope, what we have got, that is the, now minus value is due to the, that is nothing but is a decline in the drug concentration, and next is the intercept, that is 1.8. so slope is the 0.286 and intercept is the that is 1.83. Now we will remove the value k. So the formula for value to remove the k is the k is equal to slope into 2.303. so we will use this slope is equal to slope into 2.303, enter, you will got this k value. Now this the unit for the k is the per hour. So we will write here unit so this is, then next is we will remove the t half. So the formula to remove the t half is the 0.693 divided by k. So 0 is equal to 0.693 divided by ke, enter. So you will get this t half is 1.05, that is will be in the unit for this t half is the hour. Next we will remove the Vd. So before going to remove the Vd, if you have now you have seen the Vd formula, the Vd is equal to x0 divided by c0. Now x0 is the IV bolus dose. So in this equation the 50 kg woman has given the 6 milligram per kg. So first we will remove the dose. So dose which is given, that is the 300 milligram. 300 means 50 multiplied by 6, that gives the 300 milligram. So now we will remove the Vd. Vd formula is what? That is the dose divided by the plasma drug concentration. So now going to the plasma concentration Vd, we have to remove the C0 at the 0 time concentration. So to remove the 0 concentration we have to add the formula, that is equal to 10 to power intercept. So this is your C0 concentration. Now we will remove the Vd. Vd, that is the x0 divided by C0. So x0, that is milligram, we will convert it into the microgram. So we'll convert it into the microgram. 3 divided by, multiply by 1000. So in this way, so now we'll add this value is equal to dose divided by plasma drug concentration. So in this way we have got this value Vd, volume of distribution, and unit for volume of distribution is the liter. So this we have got in the ml, we'll convert it into the liter divided by 1000. So 4.4 liter. So this is the unit for this volume of distribution is the liter. Then next is we have to remove the now clearance. So the formula for to remove the clearance is Vd into Ke. So we'll take this value Vd is equal to Vd into Ke. So clearance is 2.9, that is the unit for clearance is the liter per hour. Liter per hour. So in this way we have calculated the Ke, T half, dose, and initial concentration, Vd, volume of distribution. So for removing all these parameters, one should know all these formulas should be by heart by the student. So the elimination rate constant formula is K is equal to slope into 2.303. Half life is a T half is equal to 0.693 divided by Ke. Volume of distribution is Vd is equal to X0 divided by C0, and clearance, that is Ke into Vd.